Hello, I'm Conrad. Oh.
Just wait till it gets big, because this is when your song plays.
Oh. Start over then.
Restart, yeah.
I
Sorry,
didn't
guys.
know.
We get a restart in here.
Do we start now?
Alright,
I'm Conrad,
And I'm Zachary Wildpacker.
and we are standing in for Monica today.
I guess she just wanted to take a break for a little bit.
We're going to talk about desiccants right now. And desiccants are calcium chloride is used as a desiccant in the laboratory. A desiccant is a substance used to absorb moisture from the air and create a dry atmosphere.
Jeff. Chaffield?
Sheffield. It's usually placed in the bottom of a tightly sealed container called a desiccator, and substances are stored inside. So that's kind of like what you see in those beef jerky packets.
Yeah.
Those things that absorb the oxygen.
It's right beside us right now. Deliquescent compounds. Silica gel packets are used to absorb moisture from the surrounding air to prevent damage to sensitive equipment and shoes. You know, like those silica gel packets you just pull out of the shoes when you first get them. You know what I'm saying, dog? Some compounds are so... Oh, yeah, another one popped up. Some compounds are so hygroscopic that they become wet when exposed to normally moist air. These compounds are deliquescent, or they remove sufficient water from the air to dissolve completely in form solutions.
Oh hey, Monica here to talk about deliquescent NaOH pellets. So if you look over here on the left side, this is when I take my sodium hydroxide right out of the bottle and put it on a watch glass, and it's nice and dry. But after a few minutes, then when you let it sit out, it starts absorbing water from the air, and so it starts to get a little wet. And I know it might be harder to see, but that's how it is. Also, this graphic picture over here, sorry about that, but this is what happens when you don't wash your hands after lab and you spilled something on yourself and don't do anything about it. So that's why I like to have rules in the laboratory, and we follow those rules. Okay guys, back to you.
Kinda looks like the guys on meth.
Suspensions. A suspension is a mixture from which particles settle out upon standing. A suspension differs from a solution because the particles of a suspension are much larger and do not stay suspended indefinitely. Suspensions are heterogeneous because at least two substances can be clearly identified. That's like mud and water, and mud just sinks to the bottom. And protein shakes.
You can get big and swole like us. Whoa!
And sparkly nail polish for you girls.
Yay. Yay. Colloids, I believe that is pronounced. A colloid is a heterogeneous mixture containing particles that range in size from 1 nm to 1,000 nm. The particles are spread or dispersed throughout the dispersion medium. Dispersion, I apologize. Which can be a solid, liquid, or gas. Examples, paint, gelatin, and smoke. Colloids have particles that are smaller than those in suspensions and larger than those in solutions.
Milk.
Milk.
And Jello with whipped cream.
That's delicious.
The Tyndall effect. Ordinarily, you cannot see a beam of sunlight unless the light passes through particles of water or dust in the air. The scattering of visible light by colloidal particles is called the Tyndall effect. Suspensions also exhibit the Tyndall effect. As you see the beam of light passing through the water, the light particles are spreading out. That makes the glow.
It's like a lightsaber. Brownian motion. Flashes of light or scintillations? Is that right? Scintillations? Alright, that is right. Are seen when colloids are studied under a microscope. Colloids scintillate because the particles reflecting and scattering the light move erratically. Giggity. The chaotic movement of colloidal particles is called the Brownian motion. after the discoverer, Robert Brown. That sexy man in the top right corner.
That's an example. Food coloring in water without stirring it. Just sitting there.
Just not really doing much, just spreading apart, looking all green.
And another example, looking at it under the microscope.
It's all pretty and moving around and stuff.
Coagulation. Colloidal particles also tend to stay suspended because they become charged by absorbing ions from the dispersing medium. Adsorption means to adhere to a surface. Colloidal particles can become positively or negatively charged. Repulsions make it difficult to form heavier particles and settle at the bottom.
Emulsions. An emulsion is a colloidal dispersion of a liquid in a liquid. I apologize for that one. For example, oil and greases are not soluble in water, but they readily form a colloidal dispersion if soap or detergent is added to water. Soaps and detergents are emulsifying agents. Time to watch this little video for a cool GIF. I don't know how to pronounce that one. It's oil and water. Test Tuesday. Chapter 15 review due Tuesday.
Flip chart due Tuesday. So we got a lot of stuff to do on Tuesday, so get to it.
And I'd like to give a shout out to my main man, AJ Dixon, in the back corner, working on his stuff in the lab area like a good student should. You guys have a good day.
Is Connor A? Oh my God, you cut me off!
We're recording right now.
Oh.
Okay, Connor, say
No.
yours enough.
She'll edit it. She'll edit it. Get back over here.
It's still playing.
See, this is what people do to me, Chemistry 1.
Go!
This is Connor A signing off.
This is Ron Burgundy.
You say
Stay classy, San Diego.
Okay,
I was
now
thinking-
it's done.
I was thinking wrong.